Visitors and recent arrivals to the Bay Area region are often puzzled by sharp changes in the summer weather from day to day. Some days, the bay and its shores are totally fog-bound, but other days are clear and cool. The fog seems to go in cycles. In this video, we will explain the phenomenons that make summer in the Bay Area so unique. Specifically, we'll be covering the jet stream, multi-cycles, the inversion, high fog and effects of fog drip on plants, fire weather, weakening of the westerlies, and last but not least, wind and fog gaps. Enjoy. Until the middle of the 20th century, weather observations were primarily confined to measurements of events on the land and sea surfaces. Then, during World War II, pilots flying at previously unattained heights of 30,000 feet and above discovered at the core of prevailing westerlies a jet stream, a river of air moving at 150 miles per hour or more. This powerful current, which flows from west to east over the Pacific and across North America, carries with it some storms that bring rain and snow to the continent that affect local weather in ways that were previously unexplained. The jet stream travels not in a straight line, thrust, but in a weaving pattern that loops north and south in unpredictable S-curves. The two major jet streams circle the globe in the northern hemisphere, and there are two in the southern hemisphere, but the one primarily affecting the United States is the polar jet stream. The polar jet stream's normal summer track is across central Canada, but it brings rain to a wide swath of the continent, often drenching Vancouver, Seattle, and Portland. Although California is south of the summer rainfall pattern, the remote influence of the jet stream is felt even in the Bay Area. In some summers, there scarcely seems to be any sun at all. Other summers may provide ample beach weather. The explanation for these anomalies lies in the complicated behavior of the jet stream and its associated pressure changes. Multi-cycles are a phenomenon that is very common in the summer months in the Bay Area. There are three types of these cycles: daily cycles, weekly cycles, and seasonal cycles. During daily cycles, San Francisco and the immediate vicinity may be blanketed for several successful days, while Palo Alto to the south and San Rafael to the north are beyond fog's reach. At night, however, the white mist may roll in over the coastal hills, engulfing everything from the Santa Clara Valley to the Napa Valley and as far inland as Stockton, only to be burned off in these outer areas by the morning sun. The third type of cycle is the seasonal cycle. It begins in early spring. As the Pacific high grows stronger and the valley heat increases, the stratus penetrates further inland and remains longer with each weekly cycle, reaching a maximum in August, then decreasing through September. Finally, there are long-term tendencies, perhaps too irregular to even be called cycles. Several successive summers with very little fog may be followed by several very foggy summers. On the other hand, a foggy summer may be succeeded the next year by a very clear summer. As the cool, heavy ocean air moves in across the bay and its shores, it slides beneath the warmer air. Thus, there is a layer of cool, moist air at the surface, topped by warmer air above. Anyone who climbs the hills around the bay in midsummer may be aware of the sharp changes in temperature that come with changes in elevation. At a certain height above the bay, a climber will move from the cool surface layer into the warm area above, actual climbing into the inversion. The temperature may suddenly rise 15 degrees with a rise of 20 or 30 feet in elevation. As the cool air flows in from the ocean with increasing volume beneath the inversion, it is able to literally raise the lid, forcing the warm air layer upward. Thus, the fog roof rises from an elevation of possibly 200 feet to a normal maximum of 2,000 feet. In the early stages of the daily or weekly cycle, the height in the inversion layer can often be estimated by a glance at the Golden Gate Bridge. At about the same time, another phenomenon occurs, which changes the entire aspect of the stratus on the bay. As the fog mass moves eastward, it crosses surface warmer than the frigid upwell waters of the ocean. On such surface is the sun-heated water of the bay, where very little upwelling takes place. Another San Francisco itself, and other land to the north and south. When the fog-bearing layer moves over these areas, it is heated a few degrees. As the air warms, the moisture begins to evaporate, leaving the lower air clear. The fog appears to lift off the bay and the city. It may remain at street levels in the western districts of the city, but it gradually warms and evaporates as it moves east, and by the time it reaches the downtown area, it will be some distance overhead. The higher air, not warmed by direct contact with the land or the bay, remains cool, and its moisture does not evaporate. The result is a layer of clear air before a greater ceiling, a high fog. The high fog causes a steady drip from this deposit that provides water to nurture the redwood groves and the coastal canyons. Another place of copious fog drips is opposite the Golden Gate Bridge in the Berkeley Hills, where the fog deck frequently forms on the upper slopes. Eucalyptus and pine groves planted there along the intersect large amounts of water and fog causes a rain-like deposit of moisture. The fog drip there during the summer months has been measured at a surprisingly 10 inches, an amount nearly half as great as the total number of annual rainfall in Berkeley. The fog drip is normally the only kind of precipitation that reaches San Francisco in the summertime. The jet stream and its copious rainstorms are far to the north. The rare summer shower that strikes the Bay Area region, perhaps accompanied by thunder and lightning, usually comes in from the south, as an errant mass of warm, moist air moving from the north to the ocean off of Mexico. The ocean fogs disappear in the face of hot blasts from the interior. Sunbathers spread out on the lawns of the parks and flock to the ocean shore. For a few days, San Francisco has some of its rare beach weather, but this is also fire weather, and the lookouts on Tamalpais and other mountain tops anxiously watch their horizons for signs that dried out vegetation has ignited to start the inevitable brush fires. The stalling of the jet stream affects not only swimmers and fishermen, but the region's farmers. Long periods of warm continental air, resulting from a thorough over the Pacific, will dry out the fruit on the trees and vegetables in the fields. Normally, the summer fogs along the coast make the valleys opening onto the beach ideal for growing cool weather crops such as artichokes and Brussels sprouts. The coastside areas of Santa Cruz and Monterey counties grow most of the artichokes raised in the United States. But when the Pacific High and the prevailing westerlies fail to produce the normal fog, the sun beats down on the coastal valleys and the artichokes tend to dry out, with serious results for growers. Livestock ranchers and dairy owners are also affected. Normally, fog drip along coastal areas helps grow grass from cattle grazing. Without the fog, the grass is scanty, and the ranchers have to buy more hay to feed their animals. On the other hand, when the fog penetrates too far inland and persists too long, it may spoil grapes in the Napa and Sonoma valleys. Usually, however, the delicate balance of forces is maintained, giving the Bay Area region, as the gateway between the land and the sea, it is incomparable combination of continental, maritime climates, dryness and dampness, sun, fog, heat, and cold. At any particular point in the Bay Area, the line between the two kinds of summer climates varies with the time of day, the distance from the ocean, and the proximity of the steam lines. Mill Valley, for example, on the southeast side of Mount Tamalpais, may be damp and drizzly at night and in the early morning, but enjoy bright sun in the middle of the day. Yet, it is far less foggy there in summer than at Stinson Beach, on the ocean side of the mountain. It has, in other words, more of a continental climate and less of a maritime climate than Stinson Beach. Go eastward across San Francisco Bay and over the Berkeley Hills to Walnut Creek, and the weather becomes steadily warmer and drier, more continental. Continue east over Mount Diablo to Bryan, and the marine influence is almost entirely gone. The temperature at Stinson Beach may be in the 50s at a time when Bryan boils in the 90s. In general, the same is true at any point in the Bay Area. A place further from the ocean will tend to have less of a damp marine climate and more of a dry continental climate. The Golden Gate is the largest and lowest of the gaps in the coastal range and has the greatest influence on the Bay Area's weather, but the other gaps function as little Golden Gates. They funnel ocean weather inland along steam lines, sometimes allowing land weather to move to the coast, particularly during warm nor'easters.